Hi everyone. Today is the last video of the complete solution of A levels maths paper 1 variant 3 October November 2019. So let's start. In the last two videos I completed 8 questions. Today I'll start from question number 9. The first, second and third terms of a geometric progression are 3k, 5k minus 6 and 6k minus 4 respectively. Show that k satisfies the equation 7k square minus 48k plus 36. Okay. Since this is the geometric progression question and we are given with these three terms, therefore we know that the first term is A, always A, which is 3k. The second term is AR. The geometric progression second term is always AR, which is 5k minus 6. And the third term is AR square, because the geometric progression's third term is AR square. It is given 6k minus 4. Now, as we know that common ratio R is actually term to second term over first term, or third term over second term. So the common ratio can be calculated like this. So we have all three terms, so I'll put values here. Second term is 5k minus 6 over first term is 3k is equal to third term is 6k minus 4 over second term 5k minus 6. So by cross multiplying I will get 5k minus 6 square, because this multiplied with this is equal to 3k into 6k minus 4. So open this by the identity a minus b whole square. It will be 25k square plus 36 minus 60k is equal to, multiply these two as well, 18k square minus 12k. So bring all these right hand terms to the left. So this will be 25k square plus 36 minus 60k minus 18k square plus 12k is equal to 0. So by solving this equation, I will get 25 minus 18, which is 7k square, and minus 60 plus 12, which is minus 48, and plus 36 is equal to 0. So if you see, we need to show this, that 7k square minus 48k plus 36 is equal to 0. So k satisfies this. Therefore, it is shown. This is our answer. Now, part 2 is that find, showing all your necessary working, the exact value of common ratio corresponding to the each possible value of k. Okay, so we got this equation from the first part. I'll solve it to find the values of k. I got extra space as well in the next step, so I should move. So I got this equation 7k square minus 48k plus 36 is equal to 0. I will solve it. You can use a couple of methods like midterm break method, bending square method, or quadratic formula, because this is a quadratic form equation. So I'll use quadratic formula because this is a bit higher values. So got A 7, B is minus 48, and C is 36. So the quadratic formula is K is equal to minus B plus minus B square minus 4AC over 2A. So just put the values. Minus B means minus into minus 48 because the B's value also got a minus. Plus minus minus 48 square minus 4 into 7 into 36, because A is 7, C is 36, over 2 into 7. So this will become minus minus plus 48 plus minus, if you solve all this with the calculator, I'll get 1296 over 14. So I got two values. One is 48. Okay, just one more step. The 1296 square root is actually 36. So I have to open the square root. Now I got two values. The one is K is equal to 48 plus 36 over 14, which will give me 84 over 14, which is 6. So the first value is K is equal to 6. The second is K is equal to 48 minus, because there is plus minus. The second is 48 minus 36 over 14, which will give me 12 over 14 or 6 over 7. So this is the second value of K. The one is K is equal to 6 and this is 6 by 7. Now he's asking the exact values of common ratios corresponding to each of the possible. So we need to find the value of common ratio, which is R, by using these two values of K. Okay. So I'll split this space in two parts. For K is equal to 6, or for K is equal to 6 by 7. So I can use this relation. Either this or this, because these both are R's. So I can use one of these two relations. I will use this 5K minus 6 over 3K for finding R from the part 1. So R is 5K minus 6 over 3K. So put the values. K is equal to 6. 5 into 6 minus 6 over 3 into 6. So this is 30 minus 6 over 18, or 24 over 18, or 4 by 3. This is the value of R with K is equal to 6. The same method I'll apply. R is 5K minus 6 over 3K, or 5 into 6 by 7 minus 6 over 3 into 6 by 7, or This can be written as 30 over 7 minus 6 over 18 by 7, or if I take LCM of the upper part as 7, it will become 30 minus 42 over 18 by 7. So our 30 minus 42 is minus 12. This 7 will be cancelled with this one because they both are denominators. So 30 minus 42 is minus 12 over 18, which is minus 2 by 3. This is the first value, this is the second value of R. So this is our part 2. Now part 3. One of these ratios gives a progression which is convergent. Find the sum to infinity. Okay. So for the convergent series, we know that the absolute value of k should be less than 1, or k should be less than 1 greater than minus 1. It is clear in the topic absolute value function. So the k should be 1 and 1. If we see that sorry, this for R actually, that's why I need to use this R. This is R. So if we see that this value is lying between 1 and minus 1, because this is minus 0.66, which is less than 1 but greater than minus 1. So this is our required R's value. So I'll use R is equal to minus 2 by 3. This will give me the convergence. So I'll use the k respective k's value, which gave me minus 2 by 3, k 6 by 7. So I will use k 6 by 7. So we know the sum to infinities formula is a over 1 minus r. So a is from the part 1, a is actually 3k over 1 minus r. Put the value of k, 3 into 6 by 7 over 1 minus, put the value of r, minus 2 by 3. So this will become 18 by 7 over 1 plus 2 by 3. So 18 by 7 over, if I take LCM of this, it will be 5 over 3. So it can be written as 18 over 7 into 3 by 5, because these two are fractions dividing each other. So I can write it as 54 over 35. So this is sum of to infinity terms. This is our answer. So this was question number 9. Now, question number 10. Question 10 is relative to an origin, the position vectors of point A, B, and X are given by this. Find AX and show that AXB is a straight line. So for this, we need to prove that A, X, and B are collinear. We need to prove that A, X, and B are collinear points. For this, we need to prove that AX is parallel to XB. So if we prove this, it means they are collinear. And collinear means AXB is a straight line. So I need to prove these two vectors, parallel vectors. Okay, first of all, AX will be AX can be written as AO plus OX. Okay. So what is AO? The opposite of OA. Opposite of OA. Change the signs. 8, 4, minus 2. 8, 4, minus 2. Plus OX. This is OX. It will be as it is. Minus 2, minus 2, 5. Minus 2, minus 2, 5. And it gave me 8 minus 2, 6, 4 minus 2, 2, minus 2 plus 5, 3. This is my AX vector. Now, the second is XB. I need to find XB. This XB will be, can be written as XO plus OB. Now, XO is the opposite of OX, 2, 2 minus 5, 2, 2 minus 5, plus OB as it is, 10 to 11, 10 to 11. So, XB will be 12, 4, 6, minus 5 plus 11, 6. Okay. I can also write it as, I take common, 2 common. So, this can be written as 6, 2, 3. XB is equal to 6, 2, 3. 2 into 6, 2, 3. So, what is actually 6, 2, 3? 6, 2, 3 is vector AX. So, I'll put the value of 6, 2, 3 AX here. So, it is XB is equal to 2 into AX. So, since a vector is a parallel to another vector, if a vector can be written as some constant multiple of the other vector. So, this condition satisfied in these two, because one vector is the constant multiple of another vector. Therefore, AX is parallel to XB, which proves that therefore AXB is a straight line. It is proved. We need to prove that AXB is a straight line. This was part 1. Part 2. Part 2 is the position vector of C is given by OC. Okay, show that CX is perpendicular to AX. So, okay, first of all, I need to find CX. CX is, again, it will be like CO plus OX. CO is opposite of OC. Minus 1, 8, minus 3, plus OX is from the previous part, minus 2, minus 2, 5. So, this will give me CX is equal to minus 3, 6, 2. Minus 3, 6, 2. This is CX. Now, from the previous part, I know that AX is 623. 623. Now, the condition for the perpendicular vectors is their dot product should be 0. For perpendicular vectors, their dot product should be 0. So, because we need to prove that Cx is perpendicular to x, so let's check that if their dot product is 0 or not. Okay. So the dot product of Ax dot Cx is Ax 623 dot Cx is minus 362. Now 6 minus 3s are minus 18. This will multiply with this. 6 and 2 minus 3. 2 will multiply with 6. 2 into 6 plus 2, 3 into multiply by 2, 3 into 2. So this will be minus 18 plus 12 plus 6, which is minus 18 plus 18, and this is equals to 0. Therefore, the dot product of Ax and Cx is 0. That's why, therefore, Ax is perpendicular to Cx. It is proved. This is our answer. Now, the part 3. Part 3 is find the area of the triangle. So, from the part 1, we know that AXB is a straight line. So, I'll draw AXB here. Here. And from the part 2, I know that Cx is perpendicular to Ax. Cx is perpendicular to Ax, it means C is here. So this is perpendicular. So if I join A to C and B to C, I will get a triangle ABC. So this is the base and this is the height. So I need these two for the area of triangle. So first of all, I'll find AB. So AB is again AO plus OB, or AO is opposite of OA from the part 1. You can check, is 8, 4 minus 2, and OB as it is 10 to 11. So after addition it will be 18, 4 plus 2 6, minus 2 plus 11 9. This is my AB. So let me check. I have no, I have this space only. So therefore AB's length means the magnitude of this vector. So this, the formula for the magnitude is 18 square plus 6 square plus 9 square, which is 441, which is 21. So sorry for this extra spacing. Now Cx Actually I have to write a bit bigger for the video, that's why sometimes I have issues with the working space. Just this is the reason. Okay, Cx is, I know the Cx from the previous part. Cx is minus 362. So the Cx magnitude will be minus 6 square, minus 3 square, sorry, plus 6 square plus 2 square, which is 49, which is equal to 7. This is the magnitude of Cx. Now, for the area of this triangle, we know the formula: 1 by 2 into base into height. So 1 by 2, base is AB, which is 21, height is Cx, which is 7. So it will be 21 multiplied 7, 147 over 2, or 73.5 units square. This is area. This is our answer. Okay, last question. The diagram shows a part of the curve and the line, this x equal to 1. We can see a curve. There are two lines, x equal to 1 and x equal to 3. The point A on the curve has coordinates 2, 3. This is the point A. The normal to the curve at A crosses the line x equal to 1 at B. This is the normal from A, which is crossing the line x equal to 1 at B. Show that the normal AB has equation this. Okay. So for this, first of all, I know that y, I have a curve y x minus 1 minus 2 plus 2. So tangent to the curve, which is actually the derivative of this, dy by dx, and this will be minus 2 x minus 1 minus 3 into derivative of constant is 0. So the value of gradient of tangent at point A, 2, 3 will be, at this point the value of gradient will be, I'll put x equal to 2 here. Put x is equal to 2 in dy by dx. So dy by dx is equal to minus 2 into 2 minus 1 power minus 3, which can be written as minus 2 into 1 minus 3. Therefore, dy by dx is actually minus 2, or gradient of the curve y is minus 2. But this is the normal to the curve. It means the gradient of normal product, since the product of two gradients of two perpendicular line is always minus 1 product. So therefore gradient of y curve into gradient of normal should be minus 1. This is the condition, because normal and curve, they are perpendicular to each other. So the gradient of curve is minus 2 into gradient of normal minus 1. So take 2 on the other side. So gradient of normal is minus 1 over minus 2, which is 1 by 2. Okay. Now I will use the formula, the point intercept form for the value of the equation of the normal. Therefore, equation of normal y minus y1, because the normal is also crossing this line, so this is y, this is x. So y minus 3 m, the gradient of normal is 1 over 2 x minus x1, which is 2. Now after simplification, 2y minus 6 is equal to x minus 2. Okay, so this can be written as 2y is equal to x minus 2 plus 6, and 2y is equal to x plus 4, or take 2 on the other side, y is equal to 1 by 2 x plus 2. This is the equation of normal, y is equal to 1 by 2 x plus 2. Okay, for the part 2, this is quite complicated part. So find, showing all necessary working, the volume of revolution obtained when the shaded region is rotated 360 degrees about the x-axis. Okay, this is the shaded region which is going to rotate about x-axis. So if we see, for our convenience, we can divide this whole shape into equal parts, in two parts, not equal, two parts. One is the area under this normal and one is the area under this curve. And because the a got x-axis 2, so it means this is 2. So the first integration will be from 1 to 2 and the second integration will be from 2 to 3. So I am going to solve them separate. I'll say this is y1, this is y1, and this is y2, because the equation of normal is y is equal to 1 by 2 x plus 2. This is my y1 and this is my y2. So keep in mind, y1's limits are 1 to 2 and y2's limits are 2 to 3. Now okay, so for this everyone knows the formula of the revolution, which is pi y square dx, because it is about the x-axis. So therefore the total volume will be, there are two y's, so one will be 1 to 2 y 1 square dx plus, this is pi here, plus pi 2 to 3 y2 square dx. So that was, these are the two y's which I was talking about. Okay, now y1 is actually the equation of normal, which is 1 over 2 x plus 2 square dx plus pi 2 to 3, and y2 is my actually the curve, equation of curve, which is x minus 1 minus 2 plus 2 whole square dx. Okay, now 1, 2, I will open this square with the identity a plus b whole square. This will be 1 over 4x square plus 4 plus 2 into 1 over 2 into 2x. This will be actually 2 into 1 over 2x into 2 dx plus pi 2 3. I will open this square as well. So this will be this square. This is our a, this is our b, a plus b whole square. So this square means x minus 1 minus 2 square means minus 4 plus b square means 4 minus plus 2 into this this will be 4x minus 1 whole square dx. Okay, now this will be cancelled with this, so this will become pi 1 to 1 over 4 x square plus 4 plus 2x dx plus pi 2 3 x minus 1 minus 4 plus 4 plus 4 this is minus 2, sorry, x minus 1 minus 2 dx. Okay, so now I'll integrate. Remove the sign of integration. 1 over 4x squares integration is 1 over 4 into x cube over 3 plus 4's integration is 4x plus 2x integration is 2x square over 2, limit 1 and 2, plus pi. I will integrate it as well. This will be x minus 1 minus 3 over minus 3 plus 4x plus 4 into x minus 1 minus 1 over minus 1, because minus 2 plus 1 is minus 1 and minus 4 plus 1 is minus 3. So this is the limit 2 3. Now this can be written as pi 1 over 12 actually, because 4 3s are 12. So I can write it as x cube over 12 plus 4x plus this 2 will be cancelled with this, x square 1 2 plus pi. This can be written as minus 1 by 3 x minus 1 minus 3 plus 4x minus 4 into x minus 1 minus 1 limit 2 3. Okay, so now I will open these limits. I will put these values here. So this will be pi. I'll put first of all 2 in place of x everywhere. This will be 2 cube over 12 plus 4 into 2 plus 2 square minus this lower limit. 1 cube over 12 plus 4 into 1 plus 1 square plus, now I am going to open this, pi. First of all, I will put upper limit 3 in place of x. So this will be minus 1 over 3 into 3 minus 1 power minus 3 plus 4 into 3 minus 4 into 3 minus 1 power minus 1 minus, again I'll put the value 2 here, minus 1 over 3, 2 minus 1 minus 3 plus 4 into 2 minus 4 into 2 minus 1 minus 1. This is okay. Now this will be pi 2 cube 8 over 12 plus 8 plus 4 minus 1 cube is 1 over 12. This will become minus, because outside is minus, 4 minus 1 plus pi second portion. This will be 3 minus 1, 2 minus 3 into minus 1 by 3, means this is plus 12 minus 4 into 2 minus this minus plus 1 over 3 into 1 minus 3, this will also minus 8, this will plus 4 into 1 minus 1. Now pi 8 plus 4 12, first of all I'll write 8 over 12 minus 1 over 12, 8 plus 4 12 minus 4 8 minus 1 7 minus 7 plus 7 plus pi minus 2, this is actually 2 power minus 3 means 1 over 8, and there is 3, 1 over 8 multiply 3, which will be minus 1 over 24 plus 12 plus 12 yes, 4 power 2 power minus 1 means 4 over 2 minus 4 over 2 plus 1 over 3 minus 8 plus 4. So take LCM of this, 12. So this will be 8 minus 1 plus 12 sevens are 84. Okay, plus pi, this can be written as minus 1 over 24, this 2 times, plus 12 minus 2 plus 1 over 3 minus 8 plus 4. So I will have to move to the next page. So keep in mind this. So after solving this, it will be 8 minus 1 plus 84 means 84 plus 8, 92 minus 1, 91 over 12 pi. So this will be pi into 91 over 12. Okay, plus pi into, now if you see 12 minus 2, 10. 10 minus 8, 2. 2 plus 4, 6. So I got minus 1 over 24 plus 1 over 3 plus 6. So minus 1 over 24 plus 1 over 3 plus 6. So take LCM of this. 91 over 12 pi plus pi into LCM, which is 24. This will be minus 1 plus 8 plus 144. Now this will be 91 over 12 pi plus, so 144 plus 8, 152 minus 1, 151 over 24 pi. So again, if we take LCM, 24, this will be 12 two times, 182 pi plus 151 pi, which will be equal to 333 pi over 24, or you can cancel it 3 with 3, so this will be 111 over 8 pi. This is the volume of revolution. So that's it, the end of last video in which I have completed this paper, October November 19, question paper 13. Thanks for watching.